So let's go ahead and try it on this one. 24. 24 is a pretty small number. So actually you can find all the factors of it not too hard. I'm actually going to show you one technique to find the factors. Now this technique I'm showing you first is not using the theorem just to say how many, right? The question didn't say find all of the factors of 24. It said determine the number of factors of 24. So I'm doing extra work right now. But let's say you forgot about the theorem and you were like, I'm just going to list out all the factors and count them up. One way to do that, my favorite way to find all the factors of a number, is to start with 1 and the number itself, right? These are both factors of the number 24 because 1 times 24 is equal to 24. And then we just kind of go through our numbers, our integers working up. So 2 times what is equal to 24? Well, 2 times 12 is equal to 24. So these are also both factors. Then we ask the question with 3. Does 3 go into 24? Yeah, 3 times 8 is equal to 24. So those are both factors. What about 4? 4 times 6 is equal to 24. So those are both factors. What about 5? Well, 5 goes into 20, it goes into 25. It doesn't go into 24. And now the next number would be 6. So you'll see we kind of circled back around on our list, which means these are all the factors. There are 1, 2, 3, 4, 5, 6, 7, 8 factors. So again, this was not using the theorem. I just listed out all of the factors of 24, and I see that there are 8 of them. And I didn't miss any, and that's very obvious because it's such a small number, we kind of exhausted all of our options. Now, if it was a larger number, the theorem is useful if you're just asking how many factors are there. So again, the way the theorem works is you have to list out the prime factorization. So this is different than what we just did. The prime factorization, you're just listing out multiples and circling primes along the way. So let's go 4 and 6. All right, 2 and 2, 2 and 3. So the prime factorization for 24 is 2 cubed times 3. And remember, even though there's not an exponent written there, that means it's a 1, 3 to the first power. So to find the number of factors, which I'm just going to write n is the number of factors, it's going to be 3 plus 1 because of that exponent there, always plus 1 on top of whatever exponent is there, times 1 plus 1, 1 plus 1. All right, these first numbers are coming from the exponents. The plus 1s are always plus 1s. We multiply these together, 4 times 2, which equals 8. So you see there are 8 factors. The theorem produces the same thing as actually exhaustively finding all the factors and then counting them up after.